Hey guys, today we're going to have a look at something a little bit different on the electrical side. I have with me here my Fluke T110 voltage tester or voltage probe. The probe comes with quite a nice storage mechanism, such as this, which is actually used for opening some of those flat pin sockets which have got protection on. This does detach, and when you have your two probes, this can be used to insert into a 2-pin socket, which is quite handy for quick checking, or you can separate your probes and you've got your hot and your neutral probes for going around your DB box, plug sockets, whatever, and doing testing. The meter does have the function for continuity testing, which is quite handy for just checking a wire, conductor, insulator, whatever the case may be. It also includes a basic little torch just for checking things out and making sure there's no Nunu's waiting for you in dark places when you're going and measuring voltage. And yeah, it's great for simple use if you just need to get an indication of voltage, to check for something if it's hot or not, in other words if it's live or not, if it's safe for you to work on, and for those basic scenarios. Basically, it's not meant to replace a dedicated multimeter or digital multimeter or any multimeter for that standard, but it does give you an indication of DC AC volts from 12 to 690. I've tested it down to 9, but it cannot give you an indication of 9, it just shows you 12. I have used it for checking continuity, for checking live circuits and stuff like that, for tracing circuits, and for all sorts of general stuff. So let's have a look at this thing on the bench. Hey guys, so let's take a look at this Fluke T110 voltage tester. You get various models in this range. The model that I have is the T110, because I thought if I'm going to go in with the T150 or one of those with a meter on it, then I may as well make use of one of my multimeters or something to get the job done. I want the probe to be basic, simple, quick to use, and pretty much the only thing the bigger models have is the LCD display. Again, like I said, not really needed, because this is meant to replace my traditional sort of voltage stick that I would use for checking hot circuits. We do use the non-contact sticks as well, but sometimes you actually need a probe with a bit of a voltage so you can actually check what the voltage is. This one here can do AC and DC. It can tell you whether it's AC or DC, the polarity of the DC if it is DC, the phase rotation. It can also check continuity, and it can simulate an earth leakage at a very basic level. It also has a built-in torch, which is quite nice. So these little guys really do have an advantage for an electrician going in to see an installation, and I'm basically going to go through some of the basic use sort of samples of this unit so you guys can see how it works, see what sort of display it gives off, and we can go from there. Here we have use scenario 1. We've got a 12 volt power supply, DC. We basically jack in, it tells us we've got 12 volts, polarity positive, DC. If we were to reverse this, it would show us polarity negative, so now we know the negative is on the positive probe, 12 volts. So there you have the sort of basic DC application of one of these probes. Just to show you guys as well, you have the continuity feature where it can check continuity, which is quite nice. And now we're going to take a look at a couple of AC 230 volt rails and see what it's all about. The nice advantage is this unit does clip together, the negative and the positive, creating a sort of 2-pin socket tester per se, but it only works with the 2-pin sockets. Now let's throw 230 volts at it, and there you can see 230 volts, it's high voltage, danger, AC, and we've got a left rotation on the phase rotation. So that's quite simple. It basically lets you know what's actually going on. Very nice little portable tester. Hey everybody. So what I'm going to do is I'm going to show you guys different ways of measuring mains voltage, starting with the Fluke T110 test probe over here. The way it should be done is you remove your insulation and you have your two probes. Now personally I believe in not having more than one sort of point in the air, but I mean if you wanted to test phase to phase, for example, we could go like that and it will show us, right, we have 400 volts AC showing up on the tester, and against the other phase we should have the same thing. There we go, 400 volts AC. So we know this is our 3 phases over here. Down here we have our neutral bar. So between the neutral bar and there we have 230 volts here in South Africa. Now just to check that, we basically can connect across here to here, and there you'll have your 230 volts display showing up, and we can actually see a rotation left. On this one, again same, and on this one again same. They're all 230 volts. The phase to phase is about 400 volts here. So there you have it. That was a basic test of using the probe to check circuits, if a circuit is hot or not. So let's say, for example, you've traced it down to this circuit over here that you need to work on, and you need to make sure that circuit is dead. Now that is a single phase circuit breaker. So you would go from your test point over here, and then you would throw it onto that point over there. Okay, it's currently live. Turn it off, check that it's dead, and move on. Again, using one hand as much as possible. Now, if you're not using one of these test probes and you're using a multimeter, there's a few things you need to know. One of them is make sure that your meter is safe and it has a fairly decent cat rating, such as this Bremen TBM 812 or the 829s or any of these, which are cat 4 1000 volts. You can switch it onto AC volts like so, and then again you could take your probes pretty much phase to phase, same as we did before, measure, and then we've got our 408.4 volts, 50 hertz. Let's put the light on. There you go. 408.2 volts, 50 hertz. All very well. And then, of course, you can also check from, let's say, your negative bar to your terminal, and you'll have your 230 volts, 50 hertz. Very nice. So that is a simple way of checking if a circuit is live or not. Guys, it's very important to take note of safety when working in DB boxes, safety glasses, some nice insulated gloves or something, just so that if you do touch something that's hot, you're not going to get electrocuted. And also, if there is an arc explosion or anything like that in one of these DBs, you don't get any eye damage or anything like that. So it's very important that you take care of all PPE standards, especially when working in a 3-phase DB such as this one over here. Guys, they are dangerous, so please take note. Don't try this at home unless you actually have an understanding of what's going on inside one of these meter boxes or one of these switch boxes. Thanks for watching.